Welcome to Homework Lib.
Hi, so in this question what we're doing is the titration of 20 milliliters of 0.15 molar potassium hydroxide being titrated with a solution of a strong acid of 0.125 molar, and the strong acid in question is HClO4. Okay? So first of all, let's remember that HCl4, what is going to happen when it comes into contact with water is that we're going to generate hydrogen ion plus ClO4 minus in a very quantitative way because this is strong acid, right? So the amount of mole that we add of HCl4 is going to be equal to the same amount of mole of H3O plus that we add into solution. So the first step is finding the amount of mole that I have initially of OH minus, and that is nothing but employing the definition formularity, that is amount of mole divided by volume. This is the volume in liters, so 20 times 10 to the minus 3 liters of NaOH times the concentration, 0.15 molar, which it is going to give us at 3 times 10 to the minus 3 moles of KOH in our solution, or of OH minus in the solution. Now, in order to calculate the pH after the two additions of acid, we're going to do the same thing, but with the amount of acid that we added. So, first step, we added 24 milliliters of acid. This corresponds to adding an amount of H2O plus equal to 24 times 10 to the minus 3 liters multiplied by my concentration of the acid, 0.125 molar. This is going to give us 5 times 10 to the minus 4 mole of H2O plus. Sorry, 3 times 10 to the minus 3 mole of H2O plus. So what happens in the first addition? Here we are at the equivalence point, because the amount of H2O plus, it is going to be equal to the amount of OH minus that I have in the solution. That means that the pH, since I'm going to have a complete neutralization, it is going to be equal to 7, the one of water. Now for part B, we added 30 milliliters. The amount of mole of H2O plus that we're going to get is 30 times 10 to the minus 3 multiplied by liters, of course, multiplied by 0.125 molar. This amount of mole corresponds to 3.75 times 10 to the minus 3 minus 3 mole of H3O plus that we added into solution. So in order to calculate the pH, we can go ahead with our ice table. We have our reaction. The strong acid is going to react with the OH minus that we have in solution to produce water. We can do our ice table in terms of amount of mole for sake of simplicity, and at the very end we're going to do the calculation of the concentrations. So we start with 3.75 times 10 to the minus 3. We initially had of OH minus 3 times 10 to the minus 3. So the limiting reagent is OH minus. We are going to be after the equivalence point, so the pH of the solution is going to be given by the excess of acid that we added. Here we're going to have minus 3 times 10 to the minus 3. Since this is my limiting reagent, this is going to give us something close to 0. And over here, 7.5 times 10 to the minus 4. And recall, these are moles. Now we can do the calculation for the concentration of H2O plus. For that, we require the total volume of our solution. We initially had 20 milliliters of sample, and we added 50 milliliters of sample. And we added 30 milliliters of sample, giving us a total of 50 milliliters. The concentration of H2O plus, it is going to be 7.5 times 10 to the minus 4 mole divided by my total volume given in liters. So 50 times 10 to the minus 3 liters, giving us a concentration of 0.015 molar of H2O plus at this point. That means that our pH, that is minus the logarithm of the concentration of H2O plus, it's going to be 1.824, which is approximately 1.8 if you want to run it up to only one significant figure. And that would be all. Thank you very much.